I once again welcome you, all of you, for the lecture series of electrical power quality. Today is we are discussing the topic on DC and low voltage network. How the DC is acted whenever you are connected to the low voltage network, or how to add the DC to the low voltage network. There are some constraints to add this DC to the low voltage profile networks or distribution networks or whatever. So there are some conditions to apply the DC. At the same time, you have to run some tests to verify whether the DC support that low voltage network or not. Whether all the rules and all the conditions and the tests will pass the DC. So then after we can add the DC to that low voltage distribution networks. Okay, so once again, I will go back to the previous lecture, what we are discussed on the previous lecture. So now see this, we have to see a low voltage distribution network. We are dividing into the two different categories, a simple two different categories. It's nothing but the a secondary network or a street network and a spot network. A secondary network or street network are located is nothing but in the area wise you can supply the power to the area based on the area, but spot network is supplied to the power as nothing but a buildings, large commercial buildings, some small type of industrial buildings or industries are like the spot networks. So whatever it may be, this spot network and second network are given are powered by using some sources that we can call it as a network units. This network units consists of the some primary feeders as well as some transformers and protective equipments. All are located at the substations that we can call it as the network units. Okay, what is the objective of this here? So what is the objective of this design? I think this radial designing, this radial, this is the radial design. Radial. What is the objective of this radial design? To maintain the continuity of the power supply. That means to increase the power quality. To increase the power quality is our main. So this is a one type of the radial network. Now see this. This is the radial network. You can, so this is substation one. This is the substation two. You can assume this is substation three. This is a feeder one. This is a feeder two. This is the feeder three. What is the advantages of a radial feeder? If any one of the feeder got failed due to some external problems or internal problems, this circuit breaker is open that feeder. Remaining two feeders will supply that power to the loads. So that may be maintain the continuous power to the loads. So whether you add the DC to this low voltage profile network, the DC must have the some properties, or it must have some capability to drive the loads and all the things. Before going to that, what are the fundamental network operations? So now what is the operation of this one? What is the operation of this one? We are already discussing last, but once again you can see this. So what is the fundamental operation of this one? This is the radial network. Simply again, this is the radial network. So this fundamental network operation is mainly based on the protection protection. It's mainly based on the some protection. Okay, whenever you see this protection here they can assume that there is a fault in this one, fault in the feeder 2. This is feeder 2, or suppose this is feeder 1, or suppose this is feeder 2. You can assume this one. There is a fault in this feeder 2. What will happen here? This feeder may be open. This feeder may be open. This is a circuit feeder. It opens this feeder. So the remaining feeders will drive the loads by supplying some power feeder 1 as well as the feeder 3. Feeder 2 is open due to some internal as well as the external faults, whatever it may be. These are the circuit breakers. These are the circuit breakers are some protectors. How to open the circuit breaker? Based on the relay. This type of the network, the relay setting is very sensitive. That sensitive level is 0.1%. This is a very low sensitive level. Sorry, this is very high sensitive level, sensitive value. This is very high sensitive value. Highly sensitive. Now see this. This is the percentage of the rated power network of the transformer to relate to pickup level. Pickup level means here the operating level. The current, when that current level is changes this much level, 0.1 level, then which level? A reverse power. Uh, Remember here we are using the relays at reverse power relays. Reverse power. Remember our old topic is depends upon this one, reverse power. And now there is a power changes at point 0.1 changes, 0.1 percentage changes in the power, reverse power. So this relay will identify that one. Then the circuit given the instructions to the circuit breaker, then according to that circuit breakers will operate. So now see this here, the case here. Why the greatest sensitivity, 0.1 sensitivity? Because we are operating at the low voltage distributions. Low voltage means the loads are changing rapidly, the loads are increasing rapidly. That means the change, increasing means are changing, plus 1 to the plus 2, nothing but there is 1% is change, so that is a change in changing. But even though the changing happening in the system, the current level is also changing. But even though that is this type of variable network, why you can tune this relay to the very sensitive level? Because of this, this is the reason. Because the network protector must operate for all type of the faults, for the all type of the faults. Okay, you can protect the system or these feeders from all type of the faults. Okay, that's why you can tune this delay to the very less levels, a very sensitive levels, very sensitive levels. So for this type of network, we are going to add our DC. Okay, for this type of network, we are going to add our DC. Okay, so how is it possible? So there are some categories. There are some categories. Okay, now see this, how it will be added. You can see this, you can see this point, a summary. You can see this, a summary of for network interconnection issues. This is the second point. What is the first one? A fundamental network operation. Okay, what is the second one? The summary of network interconnection issues. Okay, what is the summary of network interconnection issues? There are some 6 points they can summarize here to interconnect the DC to the low voltage network. It may be occur some problems. It may produces, it may be generated some interconnection issues. These are the some of the interconnected issues are discussed here. Some issues discussed here. Whenever you are interconnecting this DC to this low voltage network, there are some interconnection issues are arise. These are the 6 different type of interconnection issues arising in this one. What is the first one here? What is the first one here? So now you can assume that we are taking the spark network on each and every example and each and every case. A spark network. A spark network. This is the one type of the spark network. You see this. This is the one type of this spark network. This is the spark network. This is the spark network. We are assuming for all our cases, all our examples, we are assuming a spark network here. Okay, whenever we are adding a DC to this spark network, remember the spark network, it is not practical. Whenever you are directly add, remember you can see this. Whatever it may be, spark network, both are same. Whenever you are add DC, or suppose DC here, to the spark network directly, it is not possible. Directly, remember the word directly, it is not possible because of the protection, because of the protection type we are using. You see this, because of the reverse power method of protection in the networks. What will happen when you are add, so for suppose this is the feeder, this is we are at DC here. What will happen? The power capability, the power flow in that feeder is changes, so this my relay is operated. So reverse power relay is operated. So directly you can add, practically it is not possible to directly add this DC to the spark. Okay, so what is the second case here? So our protective equipments are designed based on the standards ANSI IEEE standard. These are the standard number CS 571244-1994 are the standards. Are the standards we are built according with this productive system, reverse power productive systems. Okay, this could not be allowed across an open switch DC onto the network. So okay, well, according to the standard, so it can also says that there are also not required to interrupt fault currents with higher X by R ratios than those usually encountered in the low voltage network system. What is the meaning? What is the X by R ratio? What is X by R ratio here? Here you can calculate the X by R ratio here in this cases. Transmission line distribution network expire ratio. It is not the ratio of the transformer or not the ratio of the machines. Synchronous machines are another thing. What is the expire ratio? Expire ratio is nothing but this line expire ratios. This line expire ratio. When you add the DC to this one, so this relay will activate that one, and the time the expire ratio is definitely changes. So it is not, it is encountered because of some problems. Okay, we can assume here, we can assume this diagram. We can assume the expire ratios. The expire ratio changes. Okay, when the expire ratio changes, you know that most of the relays work on the some categories like voltage, current, the parameters like voltage, current, and frequency. These are the three parameters where our relays mostly working. When the expire ratio changes, definitely current as well as voltages are changes. Okay. Okay, what is the third case? The fault current delivery from synchronous DC or this synchronous machine we are using a DC as a source as a synchronous machine to external fault can cause this network protector to open, potentially isolating the network. Whenever we are interfacing or interconnecting a synchronous machine type, nothing but a gas turbine or synchronous generator type or DC, we are interconnecting to the low voltage network, you may be getting some problems. This is what is the problem that one causes network protector to open, potentially isolating the network. What will happen if the network protector is open? What will happen? Protectors means the circuit breakers, some isolating switches, and then lighting is all the cases will come under network protector devices. So what will happen when that network protector is open? So it can be isolated the DC from the system. Yes. Yes, this we have this. See this for for suppose this as one of the network product. What will happen here? So whenever DC is installed here, it can open. What will happen? So it can be isolated from the network. Isolated from the network. Yeah, yes. Utility source. The network relay may be repeatedly attempts to reclose the protector. So once it is open, what will happen here? It can clear the fault or something, whatever. Then then the relay is tried to close the or operated to close the circuit breaker to restore the power. And the time and it leading to the distraction of protector and the possibility of catastrophic failure of the network. Catastrophic, catastrophic failure. So it tried to attempts, but because of this synchronous machine connected to that one, again it can opens. It closes, it opens. It closes, it opens. It may be possible to get damage to the system. Okay, now see the network relays are a part of that integrated system, are nothing but the power system. So we cannot eliminate it that relays uh, operate the DGs to the low voltage network. It is not one. So how this connected? How to connect this one? This is connected to this bus tie or also some tie line. So see this. Whenever if the bus tie breaker is open, Our second substation is used to supply the network, then there is a possibility that protected cycle would occur under light load conditions. Remember this point. The addition of DC to that network bus will worsen these conditions. This point, you can see this point carefully. Important point here. This this is one of the important point in this case. Whenever you are adding DC to this low voltage profile network, see this. Whenever whenever you can see this. Yes, you can see this. See this here. Whenever we are connecting, this is the one of the bus bar. So we are connecting our generator DC here, this bus. See this DC to this bus. For suppose if this bus is open, now see this. These are the switches. These are the opening. These are the fuse. These are the fuse. These are the open switches. Open. For suppose this is open because of some relay operations. This is open. This bus switch is open. For suppose this switch is open. This bus switch is open. What will happen here? Happen. Second substation is used to supply the network, because any one of the substation, we are not saying that exactly the second substation, that it is based on the where that our switch is open. It is near to that substation 1 or substation 2 or substation 3. If it is open at near to the substation 1, then secondary substation and third substation will supply the power to that and the network and so on. Okay, so this will causes some burden on that systems. Okay, so this will maybe more damage to the systems and all. You see this. First suppose if there is a fault here, first suppose there is a fault, a generator is connected, a local generator is connected, nothing but a synchronous type of generator, synchronous generator, synchronous generator. A fault is occurred here. A fault is occurred here. As a fifth point and as a fourth point says that, sorry, as a third point says that, you see this, the fault current delivery from synchronous DC to the external fault can causes network protected to over potential isolated network. This is one. Whenever there is a fault will occurs in the systems, will may leads to the isolating. Now see this, the direction. Now see this, the direction. Now see this, the direction. See this, the direction, the fault current direction. So that may be open the synchronous machine to isolate it. So these are the some, sorry, these are the some different types of the problems whenever you are interconnecting this DC to this voltage distribution network. So these are the problems. Then what are the techniques to uh, add this DC to the low voltage distribution? What are the techniques? Those are the problems. Then what are the techniques? How to avoid that problems? Then we are coming with some different technical methods to add this. Okay, to add this DC to this network. So one of the method is the inverter based DC. One of the method is the inverter based. We are using an inverter based DC because we are connecting an inverter based DC. Now see the inverter based DC. A DC. See this. This is the inverter. This is the inverter. Nothing but we are connecting here a DC to the AC network. Nothing but a solar type of the network we are using here. A solar type of network for our assumption. We just assume we are using a solar based, a solar based. Here this is the inverter. This is the inverter. Some AC to the DC or DC to the AC inverter. See this. This is the AC symbol. This is the DC symbol. So this DC power is injecting here. So this inverter is converted into the AC, then giving it to this uh, the smart network. Now see this direction. This direction. So why inverter based we are using? Why inverter based here? Why inverter based? Why this inverter based here we are using? Because of it can reduces the fault current. Reduces the fault current. Okay. Okay. So yeah, this is first one. This is one of the method. This is one of the method. Remember, this is one of the method. This is one of the method. Okay. This is one type of the DC method to interface this. Okay. There is some precaution here. Precaution whenever you are adding this DC to this directly to this network. The DC load, the load on the DC or the DC capacity never exceeds the this spark network load. Remember, the DC. This is the point. Most critical aspect here. That's why I'm highlighting here in bolding this word. A most critical aspect of DC network is not only the inverter based. Any of the DC network, any of the DC we are adding here, it never crosses the or it never exceeds the local load. This is the local, not much part. This is the second type to interface this DC to use the tie line. Tie line to use the tie line. This you can see this drops, this dotted line. You can use you can change the color of this pen. You can see this. You can see this. You can see this tie line. You can see this tie line. Tie line load scheme. Use a tie line load scheme that senses the total incoming power to the facility and adjusts the DC power output to ensure that the power flow is always inward, nothing but less than this one. Tie line power, tie line load connector, tie line load connector. Whenever you are using this technique, how much amount of load we will deliver by using this DC to this uh, spark network to our load network. So it is always less than this. Remember, this DC driving capability and low capability is always less than this spark network. Always less than this part. Then, then what are the other approaches? We are discussing two approaches. So whenever we are adding inverter based as well as in addition to this inverter, we are adding some tie line. These are the another approaches. Third approach is one of the third approaches. Size the DC to be less than the minimum load that never exceeds the network within a margin for a sudden loss of large load. The size the DC. Here, this point we are discussing this point. Discuss this point. Can size the DC much less than that of the or slightly less than that of the local load. Then what is the fourth case here? The total incoming power to the network and strip the DC whenever the inward power flow falls below the set values. This is the one of the case. This is the one of the case. Okay, simple, very simple. Simply using the Thailand power, one of the case, and as well as simply using the inverter based DC. And at the same time, the one precaution is that whenever you are adding DC to the low voltage network, the DC total power never crosses the load of the spark network or local network. That is the reason. These 2 points are also elaborated. Okay, first suppose if there is some cycling problem is arranged in the system, some problem is arranged in the system, there is a possibility that arranging that problem also. Okay, so that problem is arranged in the system. You know that what is the main drawback of this local distribution network reversal powered technique to protect the entire system to relay setting time to the 0.1%. This is one of the main drawback. Whenever there is a problem, you can see these dotted lines. You can see these dotted lines. A cycling, an instantaneous, see this, an instantaneous current is produced in the system because of some problems. So this relay will activated that instantaneous high currents and open the system and clear the fog. But because of this sensitivity, so the relay is every time operating. There is small changes in the current levels in the systems. So that is not the feasible solution whenever you are adding DC to this low voltage network. So we are trying to decrease this sensitivity value to the some levels. This graph will shows that one and adjustable reverse power characteristics of the relay. So these are the adjusting threshold value levels. You can see this. This is time to operate that relay, as well as whenever this time to operate that relay is increases, that means you are decreasing the sensitivity level. Nothing but if it is 0.1, can nothing but 10% you are increased to the 15% of that. Nothing but it is 10 value, 10 amperes. For suppose if it is a 10 amperes, you can increase up to the 1.5 or yes 1.5 15%. This is sorry. Yes, you can increase up to the some 1.5 value or 0.2 value. For suppose 0.2 value. For suppose 0.2 value. You can increase the level up to 0.2. You can decrease the level up to 0.2. But the time to operate that relay, yes, this is a real operating time. Remember, these dotted lines will indicate the operating of the relay. Operation relay operation. The dotted lines will show the relay operation. But due to because of this less operating sensitivity and operating time, less sensitivity and operating time, what will happen? What will happen? The small changes in the DC current levels and the spot network, it can quickly operate. That may be isolating the DC every time. This may be the problem. This may be the problem. So that's why you are adjusting this relay time to operate some delay in the relay time. To operating time of the relay is increases. Nothing but to delay the operating time of that relay. To delaying means you can increase the you can increase the so relay activating current value. If it is 0.1, you may assume that 0.2, 0.5 and so on. So these are the some characteristics. Okay. Okay. There are some another problems is also there. You can see this an interlocking scheme. So interlocking scheme. They trip the DC instantaneously when a certain number of network protectors have to open the ensure that the network protectors will be the exposed out of phase voltages for the is nothing but this 2 points will say that for suppose the network protector has a problem. This may be causes the this may be will causes to the interlocking scheme. For suppose now see this. Now see this. If DC is interconnected on a feeder that also supplies a network unit. This is the rare case. Remember, this is a rare case. The DC is interconnected on a feeder. At the same time, it also supply a network unit. Is nothing but you know that what is a network unit is nothing but here it is. This is another term. Remember, network unit. Then if the feeder breaker is stripped and the DC is not rapidly isolated, it may be impact one or more of the network units. if it were isolated on the network bus. For this type of event of occurrence, the DC output does not have to match the other fader. Remember, this term is this term network unit. This is not only connected the as part network. This network is also connected the network, okay, units. What is the network unit definition? This is the network unit. This is the definition of the network unit. Okay. Okay, network unit. For suppose, whenever a DC is connected for the excessive case, suppose suppose whenever for the excess generation of the case, for DC is excess generated because of some reasons, DC will generate excessive power. In this case, so what will happen here? What will happen? What is our condition? The DC total capability never exceeds the spot network or network load. For suppose if it is excessive case, or if it is generated excessive power when compared to that load, what will happen here? It has, because it can causes, it has momentary greater than that load on the network bus. Under this condition, what will happen is the power continues to flows to the network bus from the feeder within the interconnected DC. It keeps the protector closed. This is the first case. For suppose very less than that case, you know that this is our assumption, but rated below that rated value, what will happen? The network protector connecting the feeder within the generation metric. Again, such condition would have a protector separating two independent systems. Very easy. You are not confusing this one. Very easy. See, once again, I will show that you. For suppose, whenever you are adding a DC, remember what is our aim? Adding a DC to this low voltage network. First of all, you have to know that what is a low voltage network and how this low voltage network is divided. This low voltage network is divided into the two categories, secondary and spot. For our assumption purpose, you are taking it as spot network. Okay, so how this spot network is designed? So radially, spot network is nothing but a radial distribution system, one of the radial distribution network we are connected. So which type of protective scheme we are used here? A reverse power protective scheme. So the sensitivity of the tool is very sensitive, 0.1% up to the 0.1%. Why? Because to protect the system from all type of the problems. Okay, so this okay, for this type of network, whenever you are interconnected that one, you have to follow the you have to measure some quantities, or you have to follow uh, some rules to add this one. So these are the some problems while you are interfacing this voltage network. What is the first one? What is the first one? First one is, so DC, you are not directly connected the DC to the spot network. You must maintain the tie line first one. So it can have the expire ratio problems. So you cannot add this synchronous DC directly to the, if there is a problem fault in that one, you can simply isolate it that way. Okay, these are the some problems. These are the problems. So now see this. These are the synchronous type of the general. If there is any fault here, so it can simply disconnect the entire general. So you have to follow some different techniques to interconnect this DC to this low voltage network. What are the different techniques? We are using some inverter based generating. Yes, these are the inverter based generating. In according with the tie line. This is the tie line. In according with the tie line. Why inverter based? What is the reason for inverter based? To limit the fault current. Why tie line? Why tie line? Why tie line scheme? The DC power output when it flows always inward direction. It can measure the tie line will measure that the DC will supply the excessive power to this network. It can shows that if it is excesses, it will be the problem. You know that what is the condition here? This is our condition. What is the condition is here? It must be less than DC power must be less than the total load. Okay. Okay, for suppose if there is some problem is arises in the system, this part network is quickly uh, senses that one and clear that fault. This may be problem in case while you are adding DC to that network. So every time DC is isolated and reconnected isolated, this will be the problem. So that's why we are adjusting time of this reverse power relays. This is the some characteristics of the relays. Adjusting reverse power of the relays. You can adjusting means the sensitivity of the relay you may be decreased here in this cases. Okay, because these are the some another problems we are getting for suppose an excessive generation case, for suppose an low generation cases. Okay, you have to measure this one and you have to place the DCs on the low voltage distribution. But we are not at all discussing the where you can place that. We are you just see that which techniques we are used to place the DC or interconnect the DCs and other things. Okay, yes. Thank you for all of you joining today's class. Thank you very much.